Flat puzzles are well known by everyone, but 3D puzzles present a different challenge. These three-dimensional puzzles are first conceived with computer software. Good blades are needed to cut puzzle pieces. Here are the blades for the master die, which will cut out printed sheets of different models. This rubber will be used to eject the die. The master cutting die is unique to each puzzle. It is the specific pattern used to make the puzzle. They measure it meticulously to obtain a perfect register. It's imperative that the die not move during the cutting, otherwise the pieces would be cut at the wrong points, so they very firmly secure it in place. The carbon of the die is positioned. It's somewhat like printing the master. Alignment is again verified, a highly important step which assures the quality of the final product. Finally, they install this large metallic plate, which is the cutting base. It will be on this surface that the master die will strike. Once measurements are finished, the drawer of the die is slid into place. This press cuts the pattern seen on the puzzle. Here's how it works. The sheets, or printed cardboards, go into the drawer one by one, where they are cut according to the master model. We clearly see the press making the cut in the puzzle sheet. The cut sheets pile up on one another, and at this checkpoint, they verify the precision of the cut. They make sure that every piece is correctly shaped. Now they go to the foam support of the puzzle. This guillotine is used to cut the polyethylene sheets onto which they will glue the cut images. Foam sheets are inserted into this laminator, heated to 232 degrees centigrade. The sheet with the design on it is glued onto the foam with a thermosetting adhesive. Now they glue the printed sheet onto the foam sheet. Once the adhesion is finished, the puzzles are stacked on one another, and they proceed to the unbuckling operation. By pulling, they remove the surplus cuttings. The same design is printed several times on a sheet, so they must separate each puzzle. This step is called the reduction of the models. Now the pieces have to be separated. This decorticator handles this task and sends the pieces down a chute. Packing cartons arrive already made up, and the puzzle pieces are placed in their boxes. No less than 15,000 puzzles are produced here each day. Since it began operations, the company has created more than 300 different puzzle models, from quite simple ones to much more complex designs. The largest of them contain a total of 3,146 pieces. And you need real patience for this one.
What is biophotonics? Well, bio is short for biology. Photonics is the physics of light. Biophotonics uses sophisticated imaging and other sensitive optical instruments to conduct biomedical research. Biophotonics has a range of uses, from medical diagnosis to drug screening. In the golden years of animated film, teams of animators would draw every single illustration by hand. Today, they do much of their work by computer, but that doesn't mean it's any less artistic. It all starts with a screenplay, a script containing not just dialogue, but also physical descriptions of the characters and background scenery. The art director begins creating the characters. He draws in pencil. When he's finished, he traces the drawing in felt pen. Then he erases the pencil marks. He adds shadowing to create relief. Once he's drawn all the characters, he starts the backgrounds. And then the objects that appear in the backgrounds. The storyboard artist blocks out the film on paper, drawing by drawing. The production team will follow this storyboard the way a dressmaker follows a pattern. They blow up the drawings, scan them into the computer, then play them back in chronological order. This creates what's called an animatic, a two-dimensional version of the film minus the animation. Should the director now decide to change, say, a ground-level view of the street to an aerial view, he has the artist redraw the street from that new angle. Meanwhile, the animators work on bringing the characters to life. Using specialized software, they build a skeleton to fit inside the character's body. When they move the skeleton, the software makes the body move with it. They make the characters three-dimensional using a technique called wireframe animation. First, they build the shape of the character using a wire structure. Then they add color and clothing. They further refine the character by modifying facial features, by adding texture, and by shadowing. They use specialized software to synchronize the character's mouth with the dialogue. The technician works syllable by syllable, picking the mouth movement that matches each sound. It's a painstaking process that takes many months. Another animator applies the lighting effects. Lighting is as important in an animated cartoon as it is in a movie with real people. It creates relief, making everything look more realistic. The animators cut and paste the characters and objects onto the backgrounds. With the characters' movements programmed into the computer, the animators turn the two-dimensional stills version of the film into a three-dimensional animation, essentially a rough cut of the film. Meanwhile, in the studio, the soundtrack takes shape. Actors record the characters' dialogue. The sound technician weaves together the voices, the music, and the sound effects using specially designed software. They sync the soundtrack to the rough cut of the film. Then they refine the rough cut, playing with colors and textures and smoothing out the characters' movements. After a full year's work and more than 42,000 drawings, this 24-minute computer-animated film is finally finished.